Lots of experiments can only be done on bacteria and mice and other organisms. You can't do these experiments on humans, and so we rely on mouse experiments to show us what would happen to humans, and it's not always the same. So sometimes we have what's called natural experiments, and they confirm what we thought we knew. One of those natural experiments happens when twins in poorer countries are given the same environment, the same food, and yet one of them starves and the other does not. And so in this case, we found out that the difference is the biome, the bacteria and funguses and other microorganisms that live inside the body that digest the starches and turn them into other useful substances, precursors of vitamins and proteins. And so the child, the twin, that put something in its mouth that had the right bacteria, that child did much better, had the microbiome to turn the food into the nutrients that they needed. The other child had the distended stomach and the pallid look, and had the lack of nutrient disease called Kwashiorkor. It's a difficult one to pronounce. And so yes, in the past, to get rid of malnutrition, the authorities, the World Health and others, made a food supplement, a sort of protein bar, with all the things that they thought were necessary and lacking. It's expensive, and it has to be shipped around the world, and in the shipping to poor countries, it has the possibility of being stolen by people with guns. Poor countries tend to have people with guns. And it definitely helped. It seemed to help. But it's not the ideal situation. It's much better if the foods encourage the microbiomes that are necessary, rather than just a set of vitamins, proteins. So that if there's a break in these foods getting to the starving populations, which happens a lot, then their own microbiome will turn the yams or the rice, what they've got, into the nutrients they need, so that once encouraged, these microorganisms will help the human all the way through their life, rather than just a quick fix of a protein bar. And so experimenters have found out the minimum requirements to stop starvation that would encourage these microorganisms. And it's bananas, peanuts, soy, and chickpeas. And they've set up systems so that these can be grown and harvested locally to the people. So that with these four, the correct microbiome will be encouraged. So even if a little bit of the right bacteria is ingested, then it will be encouraged and flourish, and there will be less people dying of malnutrition. And so, yeah, after food technology and finding out what foods we need, we now know that given these four environments, bananas, soy, chickpeas and peanuts. Given those ones, you'll get the right microbiome for your whole life. This was based on an article from The Economist magazine. Another thing useful for teaching, parents' brains shrink when they have a baby. However, not just the mother, but the father's brain shrinks as well when I have a baby. Now, if you're trying to encourage young people not to have babies, you can just stop at that point. But I think it's worthwhile going on. Why would evolution do this? Well, after a lot of study using MRIs, the magnetic big tunnel machine that uses liquid helium to make the magnets so strong. Magnets strong enough to flip the little magnets inside your molecules. And then find out what all the soft tissues are doing. The piece that atrophies, disappears when you become a mother or a father, is the bit that's daydreaming, the bit that's about selfishness. And that makes sense. Mothers and fathers need to lose their selfishness, need to lose that dreamy lack of concentration. They need to be on the ball. Their brains shrink so that the baby has more chance of surviving. How about that? When teaching electricity, obviously lightning has to be the most exciting part of electricity. And yes, lightning hits trees, and the lightning goes down through the liquid of the trees, the tree sap, through the phloem and the xylem. And the sap turns to steam, and the steam has a lot more volume than the liquid did. And so, yes, going from a little volume to a massive volume really quickly, the bark and sometimes even the whole tree explodes due to that pressure. Oh, and the half-life of fallout after a nuclear bomb. There's lots of different elements involved, but the graphs of half-life that are available show that no, it's not 30 years from the cesium, it's 1 hour. And so every hour you stay away from the dust that's falling out from the sky, you'll get half the amount of radiation hit you. And so this is a good way of teaching half-life. So yes, if you're in the open, when the dust starts to settle after a nuclear weapon, it's not going to be good. And so yes, you go inside, not to the top of the building, because you don't want the dust anywhere near you. Even the ceiling won't let the nuclear radiation come in. You don't want to be at the bottom of the building. You'd like to be on floor 30 of a 60th floor building. At the bottom, yes, the nuclear radiation is collecting around the windows and the doors. It will come through the walls at ground level. So you want to be on the 30th floor of the 60th floor building. And the longer you leave it, the better. And I get my students to calculate if it goes from 100% to 50% in an hour, then 25%, and then 12.5%. How long do you have to wait until it's only gone down to 1%? And how long do you have to wait until it's gone to 0.1%, 0.01%? How much food and water do you need on the 30th floor to be able to survive? Morbid, but interesting. And yeah, poignant. Further to the egg in a bottle experiment, where you boil an egg and you take off the shell and you get a glass bottle that the egg will not quite fit in. And then you put something, a piece of paper, a light inside the bottle, give it a second or two. Put the egg on the top and the flames will go out and that's good to discuss why. And then the hot gases inside will contract and pull the egg in. Add on to that experiment is that then, afterwards, to get the egg out, you lift the bottle up at a good angle and then you blow so that the egg goes away from its stopper position and goes behind the egg. Your breath goes behind it and the egg comes back down, and then if you hold your mouth open, the egg will pop out the bottle and go in your mouth. Anyway, cool science. Another one I bring into my lessons is things to be thankful for. So I'm thankful for the scientists that realised that even though lead makes really good pipes to carry water, copper is less poisonous, and that's why we use copper nowadays rather than the lead that the Romans used. Possibly the lead that the Romans used was one of the reasons why the Roman Empire collapsed. Things to be thankful for. And in 2023, SciShow, one of my favourite YouTube channels, put a video out saying about how we've just recently found out more about the concrete that the Romans used. Why should we bother? Well, because the concrete we use only lasts for 20 or 30 years, depending on how much water you put in it and how much industrial dust is in there, because some buildings fall down very easily, particularly with earthquakes in Turkey just recently. And then what the Romans did, and some of their buildings are still standing 2,000 years later, the Parthenon being my favourite one in the centre of Rome, they put seawater and quicklime and the dust from volcanoes, mixed those in with their concrete, made it waterproof, and made it last 2,000 years. We are still finding out what ancient people knew. We're still learning. Things to be thankful for. I'm thankful for the Paris Protocol, where governments got together and discussed the problem of the climate change of the day. It was in the 1980s or late 1970s. The hole in the ozone layer was getting larger. It was going to become a problem, because if all the ozone goes, then ultraviolet coming from the sun will very quickly give us all skin cancer. That's one of the reasons why Australians and New Zealanders put on sunscreen, and some of the ones who are in my age group have got very brown, leathery skin and lots of skin cancer problems. But that hole in the ozone layer has got smaller. We found out what the problem was. It's the spray, or at least it was, used for house sprays, for spraying things when you're cleaning. The spray was called a CFC, and it was brilliant. It didn't react with anything, didn't cause any problems to humans. Bad. Until it got to the high atmosphere, at which point it started destroying the ozone. The chlorofluorocarbon CFCs are now banned. Not from all of the world, unfortunately, but from most of the world. No longer in your fridge, freezer, and air conditioner, and your sprays. And so as a consequence, yeah, it's healing. Climate change can be solved. I'm thankful. Other things to be thankful for, it wasn't so long ago that everything you ate had to be within 3 days' journey of you. And before the trains brought green vegetables into the centre of London quite quickly, that meant it all had to come by horse. And so that meant there was a real vitamin problem in the centre of London, because the fields nearby were getting further and further away as the city grew. And London streets were jam-packed with horses trying to get in and out and around. People trying to step around all the horse poo. So I'm thankful there for the motor car for being invented. It was a shame we didn't stick with the electric one. But the electric one wasn't the one we went with in the end. We went with the petrol one, which solved all the horse poo and the transport problems. And the steam train came along. That was I'm thankful for. Brought green vegetables into the centre of London from Somerset and Hampshire. And also thankful for the new ways of preserving food. Because yes, you can pickle and salt things, and some vitamins survive those processes, but frozen food, then it's as good as fresh. This is why I don't buy blueberries from the supermarket. It's taken lots of transport and days to get it to the supermarket. It's degraded. The vitamins have lessened. No. The freezer vans are right next to the field. The crop gets taken off the bushes, trees, tiny little bushes for blueberries, and frozen there immediately within the hour. And so it's almost as fresh as when it was picked. Whereas the ones that aren't frozen, the ones that are called fresh, are days old. Sometimes they've flown from one place to another, causing loads of carbon dioxide climate change in the process. Whereas the frozen ones, stick them on the ship, they'll be fine for 3 months. I like frozen good.